Hi, it's Mr. T here, and this is my third video looking at the physics we need to know for Level 1 NCEA. And in this video, we're going to look at the specific part of motion that is acceleration. Now, acceleration is how quickly an object changes its speed. Acceleration can be an increase in speed, it can be a decrease in speed. A decrease in speed or a decrease in acceleration is called deceleration. If I want to calculate the acceleration of an object, I find the change in its speed over the time it took to change that speed. Change in speed over change in time. An object changes its speed or accelerates because it's acted on by an unbalanced force. If you were to change your speed, if you were standing on a skateboard and you got faster on the skateboard, the reason for that is a force was applied to you and it was unbalanced, and someone either pushed you, you could have got pulled by a rope, you could have had a jet motor on your back, and you had a thrust that pushed you forward, but you need an unbalanced force to accelerate you. Now we have an equation to work out acceleration. This is it. Acceleration is equal to that delta symbol again, change in speed over change in time. The unit for acceleration is meters per second, because an object is changing its velocity, its meters per second, every second. So it's changing its meters per second. A bit complicated, I know. So again, we've got this V symbol, which is speed, measured in meters per second, and we have this symbol T, which is time. Well, let's look at some questions we might have where we use this equation to solve some problems. So here's our first question. Remember, from the last video, we had 5 steps that we'll use to solve this problem. Here they are. So let's read the question. A car constantly accelerates from stationary to 17 meters per second over 8.0 seconds. What is the car's acceleration over this journey? Now we have to read this carefully here because there's a bit of information we might not see. And the bit that we might not see here is the part where it says from stationary. What that means, the car was standing still, or its initial speed was 0 meters per second. So its change in speed is going to be 0 to 17, which is 17 meters per second. Anyway, let's find out what's the subject of this question anyway. Let's look at the last sentence. What was the car's acceleration over this journey? So we're looking at the car's acceleration or the acceleration. That is our subject. Let's look at our first quantity. As we've already talked about, it goes from 0 to 17. So our change in speed is 17 meters per second. Or here I just wrote down our speed is 17 meters per second. What's our next value? 8 seconds. Okay, it's seconds. We know seconds is going to be time. So now what we have is we have 2 quantities. We have speed, time, plus we have the subject, which is acceleration. We know the symbol for acceleration is A, so I've got A, V and T. Which one of the 2 equations we've already met are we going to use here? Right, we're going to use this equation. A equals V over T. Remember, this is a simplified version of A equals change in V over change in T. I substitute my values into where V is. I substitute 17 for V and 8 for T, and then I solve to get my answer. And my answer here is 2.125 meters per second. That's the acceleration. But I only want this to 2 significant figures. So the 2 significant figures here are I round it to 2.1 meters per second. So this is how we solve a problem where we don't have to rearrange. So what if we do have to rearrange? Well, let's have a look at that. Here's another example. A falling ball starts from rest. So someone's dropped a ball. It undergoes constant acceleration of 10 meters per second per second. Any object that falls through the air accelerates at 10 meters per second per second. It does that because there is an unbalanced force of gravity acting on it. We don't need to know that for this question, but that's why. So it accelerates for 1.3 seconds until it hits the ground. What is the speed of the ball when it hits the ground? Okay, so this is a wee bit more complex. We know that it started from 0 when we let the ball go, and when it hits the ground, it's something. Whatever the change from 0 to whatever it is at the end, that's its change in velocity. So we want to work out what is the velocity or the change in velocity. That's the subject to our equation. Oh, sorry, our change in speed, our speed. We want to find the speed of the ball. Okay, what we know, however, is we've got this value of acceleration, 10 meters per second. And we also know we've got this value that is in seconds, which is time, that is 1.3 seconds. So I want to find out what V is. I know what A is. I know what T is. Let's see if we can do that. So here's our equation. A equals V over T. Acceleration equals velocity over time. Remember, it's change in velocity over change in time. What I want, however, is I want to work out velocity. So I need to move the time away from the velocity. I need to move the time across the equation, across the equal sign. So at the moment the time is dividing into the velocity. When I move it across the equal sign, it's going to be multiplied to the acceleration. It goes from the bottom on one side to the top on the other. So that acceleration times the time equals velocity. I'm just going to flip this around. You can do this with any equation because I like to have my subject on the left hand side. Okay, so here's my rearranged equation. We learnt this in the last set of slides. Okay, and now I'm going to substitute the values in. V equals 10 times 1.3. I think most of us could do that in our head. Velocity equals 13 meters per second. And this is, we've used each of the 5 steps here to solve the problem of what is the speed of this ball when it hits the ground. It's going to be 13 meters per second. Thanks for watching this video.